Kia ora koutou, and welcome to this video series on methods of integration. In this video series, we will be investigating techniques of integration. This knowledge is assuming that you have a basic knowledge of differentiation and algebraic manipulation. So we will begin pretty simply with section 1, the power rule and notation. So let's begin with some polynomial of degree n. This is a general case. If we denote some function of x to be equal to x of n, then we are able to denote taking the integral as being I is equal to the integral sign, so that's this sign of f of x dx, where the dx shows that we are integrating with respect to x. So, as a result, we obtain that I is equal to this integral of xn to the power of dx. We can now actually integrate this function pretty straightforwardly, and this will give us a general rule that we can use, although we do need to be careful when defining this rule. Okay, so for the power rule says that we increase the power by 1. So that is x of n plus 1, and then we divide by the new power, which is n plus 1. And then we also add a constant of integration, and we say that c must be a real number, because we are integrating on the real plane, or the real line. So the only problem with using the power rule is there is a case that we can't consider and hence use the power rule for. And what we can do to find this situation is look at the denominator here. As we can see, n plus 1 cannot be equal to 0. That is because at n is equal to minus 1, we'll have a undefined function. We'll be dividing by 0, essentially. So that means the power rule works for all n, so let's write that down. The power rule works for all n in the reals unless n is equal to minus 1. And there is a technique to integrating a polynomial with degree minus 1. In fact, this is not technically a polynomial, it's an irrational function. However, we will cover that later on in the series when we reach logarithmic integration. Alright, so now let's find a wee bit more of a slightly more difficult case. The integral of xn plus x of n minus 1. Remember, we are taking the integral in respect to our variable x. So, this one we can actually break up using a law of linearity. So let's define that law. Let's say we're taking some function of x and some function of g, and we've added them together, and we want to find the integral. Then by linearity, we can actually say that this is equal to the sum of the functions integrated by themselves in respect to x. And this helps because at one point, once we reach the point, we may have a function that requires a u substitution, but the other one does not. So it is very handy to split the integrals together. So let's do that. So f of x in this case would be x to the n. So would be integrating x to the n dx, and then would be integrating x to the n minus 1. And so we can use the power rule. So what would the power rule be? What would we get? Well, we know that the first result is x to the n plus 1 over n plus 1 from the previous question. And now we just have to integrate this part here. So how do we do that? Well, again, we add 1 to the power, so we get x to the n, and then we divide by the new power, and that is n. So, and we have to remember to add the constant of integration to our integral. For c, that is real. And of course here, n can not be both -1 and n cannot be 0 in these particular cases. So n could be 0 here, but it couldn't be 0 here. So how about essentially a very similar integral, but we have constants in front of them? Well, we can use the law that we just defined, and we can write this as a to the xn dx, and we can write this as bx to the n minus 1 dx. And now what we can do is we can actually pull the constants out to the front of the integral. And what that means is we get this. We get a multiplied by the integral of x to the n dx plus b times the integral of x to the n minus 1 dx. And of course we can go to the previous question, and we actually found these results. So we can substitute those in. We can find that this is nothing but a multiplied by x to the n plus 1 over n plus 1 plus b x to the n over n plus a constant of integration. Notice that our constant of integration does not get multiplied by any constant. That is because if we did actually have them multiplied by another constant, it would just basically become another constant. So we can just leave it as a constant for c in the reals.